Hi again. We are going to talk about three-dimensional algebraic vector operations. So this is going to look very familiar. It's just instead of 2 dimensions, which is like on a flat surface, this is 3 dimensions. So if we kind of look at this, starting at 0, 0 here, we have a vector there. It's not just going right, and it's not just going up or down, it's going out. So it's going three different dimensions. I guess it's a little easier to see if we actually start in the corner. So this is 1 dimension, this is another dimension, and then we can go in, forward or backwards. So I could go that way, except it should be more parallel to that line there. Okay, so we're 3-dimensional space. So really the same idea as the last one we did. If we have a starting point and an ending point, we can rename it starting at 0, 0. So if we have some vector that's out in space, we can take it and have the same direction, same magnitude, starting at 0, 0. And we can find that by subtracting the second minus the first, second minus the first, second minus the first of the x's, y's, and z's. And the magnitude can be found the same as we did before. The distance formula, we subtract the x's and square it, subtract the y's and square it, subtract the z's and square it. So we're going to try a couple of those. This should go a little quicker this time because I think we know what we're doing. So if I'm finding the ordered pair, so here it says write the ordered triple and find its magnitude. Ordered triple. Okay, so it is x2y. So this is the terminal point. So I have to go 4 minus 5. I have to go -5 minus -3. And I have to go 6 minus 2. Okay? And this is -1. This is -2, and this is 4. All right. If we were going to find the magnitude, I would just square it. So I would subtract the 4 minus 5. Remember, 4 minus 5 just ends up being -1 squared. -2 squared, and 4 squared. So I'm just, if they didn't ask me for the ordered triple, I would actually put this in parentheses, this in parentheses, this in parentheses, and square it. So here we end up with 1 plus 1 plus 1. Sorry, we had the wrong one here. This is -1 squared, -2 squared, -4 squared. And square root of 21. And that is 4.6. Okay, so magnitude and a direction. All right, so here, if I'm just going to find the magnitude of this, just for lack of, or just for the space here, remember I can find the ordered pair first. But like in this case, if I'm just finding the magnitude, I can do 1 minus 2 squared, 2 minus 3 squared, -5 minus -4 squared, and I end up with -1 squared. This is -1 squared, which is 1, -1 squared, which is 1, -1 squared, which is 1. And square root of 3 ends up being about 1.7. Okay, so really we do it exactly the same way as we did 2-dimensional. It's just we have 3 x's, 3 y's. We have x's, y's, and z's to work with instead of just x's and y's. Okay, so same goes for adding and subtracting and scalar multiplication. So if we have a 3-dimensional space, if I'm taking D, which is 6, 4, -1, and I'm adding it to C. Probably shouldn't have wasted the space here, but so I'm going to add these two. 6 plus -4. And I get 2. 4 plus 3 is 7. -1 plus 2 is 1. So I'm just adding those. Here, I'm going to go a little bit further to the left on this one because I can see it's going to be a little bit more space. 2 times D. D is 6, 4, -1. And we're going to subtract C. -4, 3, 2. So we'll start by doing scalar multiplication. 2 times 6, 2 times 4, 2 times -1. And we're going to subtract -4, 3, and 2. Just something I would probably suggest is because we're going 12 minus -4, 8 minus 3, -2 minus 2. Something that kind of simplifies things is if you add the opposite. So now we can just do it as is, and then I'll show you to add the opposite. But 12 minus -4 becomes positive 16. 8 minus 3 is 5. -2 minus 2 is -4. Again, if I want to change this to adding +4, negative, I get the same thing. 8 plus -3 is 5, etc. So just a little easier way of keeping track of it sometimes. Okay, and then C, if I do just one more, C, and I minus 3 times D. So again, we're going to do our multiplication of 4. The one thing I just want to point out with this, it gets a little confusing, is do we multiply by -3 or +3? I would just keep that a negative, keep this, separate, and then multiply the 3. You could multiply the negative, you could multiply by -3, but then that negative has to be a plus. So let's just keep that as a minus, and then we end up with 18, 12, -3, and then we do the same thing. So I would go -4 minus 18. I would go 3 minus 12. And I would go 2 minus -3. Let me just see. 3 minus 12 is, should be -9. And then this is 2 minus -3 is 5. All right. So we'll look at one other thing. And that is unit vectors, kind of like we did last time. So just kind of like we did before, we can talk about this. Here, I'll just kind of show you here. Like we can go, if this were a 1 unit cube, this might be your I, this might be your J, and the last one is K. It would look like this. Okay, so it's really the same thing as giving an ordered pair. It's just here we're kind of saying, okay, if you have 3i, 3 of those vectors. If you have 4j, you've got 4 of those vectors. Get that up there. So, this is how we name them. 1 to the right, 1 up, 1 out, which is right and left. And then also magnitude. Remember, instead of using distance formula, if I subtract the x's and get that ordered pair, we can just take that and square it. So I'm going to write this as an ordered pair. by just going 2 minus negative 4, which is 6, 5 minus 3, which is 2, 7 minus 6, which is 1. So that's how we write it as an ordered pair. If I were going to write it as the sum of unit vectors, I would take that same new vector, because remember, I'm just repositioning it. So here it starts at this point, ends at this point. Well, that's the same as if it started at 0, 0, 0 and ended here. So I can rewrite this as we're going 6 of those little vectors to the right, 2 of those little vectors up, and 1 of those vectors forward. It's a combination of all 3 of those forces. Okay? And magnitude, I guess I need a teeny bit more space here. If I were going to find the magnitude, I could just take this unit vector and go 6 squared, 2 squared, 1 squared. Take the ordered pair. And I end up with 36 plus 4 plus 1, square root of 41 is 6.4. Okay? All right, so just one more example. Ordered pair, 3 minus 2, 5 minus negative 3, 8 minus negative 7. So there's my ordered pair. If I write this as the sum, this would be 1i, 8j, 15k. Now just remember, if it's a negative, we would go, like if we're negative 15, I would write minus 15. And finding the magnitude, so I can just take the new ordered pair and I can square it. There's no need to do the subtracting and the squaring again. So we can go 1 squared plus 8 squared plus 15 squared. It ends up with 290. And when we take the square root, that would have all 3 of those vectors, those 2 vectors combined in 3-dimensional space would have a magnitude of 17. And the new direction, when you put those 2 together, if you started at 0, 0, it would end up right 1, up 8, and out 15. And that is it for 3-dimensional space.